morning, wonderful students. So today is a teacher work day, but I couldn't leave you without some sort of instruction and resources because I know that learning math takes as long as it takes. So here we go. I owe you our announcements page. I still haven't posted it. Anyway, so I'd let you know, but you still have this lesson. 203 should be popping up on your plan. You should be seeing it mark overdue if you don't look through it. We're going to start at the beginning just for a second. I'm not going to go through the whole lesson today. I am going to jump to the practice problems. But remember, all of the ideas you've been learning through the years are now, this is it. They're all coming together. So start pulling in that prior knowledge. Start pulling in all of everything you know about decimals and fractions and multiplication and division. This is it. This is your last semester, I think, of required math. If you go on to a college prep program, I believe you do need more. I could be wrong. I don't mean, you might have to take consumer math. I'll double check there. But no matter what, this is algebra 2 is this is it. So let's just try to think about these ideas in a logical manner, but also in a personal application. Just knowing that you can learn it, just narrow in on any of those confusion points. Just narrow it down, be like, is it that number? What is that number? What is that letter? What does this symbol mean? Those type of questions. And like, we're gonna knock it out of the park, okay? We want to always be able to describe the effect the parameter has on a graph. If you aren't clicking those exploration links and sliding and just kind of thinking, where is the A? What does that slider represent to? What's happening when I change the exponent, right? We're moving away from sign graphs for the different parameters. All that is a number that is being multiplied or divided, added or subtracted to different parts of the function. And those different parts pertain to what the function is supposed to represent or the goal of the function. You're learning how to manipulate that, but outside, they're used to make prediction models like you see on the news. Companies use them to make decisions. And so just understanding how they work is a great logical practice. Pinpoint very specific ideas, and when you have bigger questions, ask them. Email, text, phone call, Teams, in chat. I love questions. I love this subject, and I really hope that you know you can learn it. I remember feeling all the same confusion. I did. So let's get going. Okay, domain, range, asymptotes, determine the zeros, graph, given an equation in the form A. Now we have more parameters, right? A over x minus h. So here is now, we didn't do this specific one for sine and cosine because it created a phase shift, which means it could have matched the sine and the cosine. So this is a horizontal shift. Isn't that cool? This is now a horizontal shift. This is the A as in the A times it, and here's why. This is one of the parts of confusion. This A over 1 over x minus h plus k. Okay, let me write this in function notation. Let's see if I can do this. A on the outside of the function, that is a vertical stretch or compression. So either it's going to stretch up or compress down. Got it? And that has to do with, is A greater than 1? Like the absolute value of gray, is that larger than 1? Because it could be negative, which then creates a reflection. Right? That's a reflection across the x-axis. Then, okay, so that's reflection. So the absolute value, if it's larger than 1, makes it a stretch. If it's less than 1, it compresses it. The factor notation is a little bit different. Oh, okay, hold on. Let me get in here. We need this h inside. I think they called it B. No, they didn't. They called it C for hours on our note page. So they would have said C right there, but that's right inside the function. See, it's inside the parentheses now, which is on our note page, AX, and then now finally plus K. And we know what this does. That's our D. So it takes our graph and shifts it up or shifts it down. exactly what k is. Up or down, whatever k is. Up and down, so it affects the y values of a graph, the vertical values of a graph, okay? And then this affects the x values of the graph, so the horizontal values of the graph. So that's what's happening here. One of the messy parts is that a looks like it's in the numerator, but this is the same thing, a times 1 over x minus h plus k, where our f of x, our original, what we call parent function, just remember sine and cosine, is 1 over x. This is our original one. We have the x minus h, we have the a times it, we have the k, and we have those wonderful notes. Oops, that's okay, it doesn't matter, it should be on here still. You scroll down. We have these notes that we're kind of using. These words, I'm with you, sometimes they confuse me. Compression by a factor of, when really they mean you're going to end up dividing it. So if it's compressed by a factor of 2, is b 1/2? Is it stretched by a factor of 2? Right? Then anyway, so there's the b, there's the x minus c, there's the plus and minus d, so it's a vertical translation up. All right, we're just looking at this, seeing if we can tell what's happening. It's very common, like I shared when my heater went out. Those technicians, they were young gentlemen that were following what they remembered about their diagrams and then applying it at my house to fix my heat so they're nice and warm. It's a very good practice of a skill to try to figure out, what does this mean? What am I supposed to do with it? Okay. Oh man, Mrs. Reynolds, right? Okay, that's our big goals for this lesson. You don't have a quiz, but these ideas will matter. Range, domain, all that means is what can go in it without making it undefined or imaginary. And then I'm going to go up here. You should look through these. These are great. Well, let's go talk about some of the practice problems on your own. Please remember, if you haven't taken the readiness checkpoint, take it. Google readiness, Google course search readiness. Take it, email me, let me know. It sets up the course with practice problems based on the scores there. So let's practice on our own real quick. What is the graph of the function? Okay. Several things for rational functions. Rational functions are similar to reciprocal power functions, very similar, but the only difference is it's kind of a big difference. A reciprocal function doesn't have to be a polynomial. In reciprocal power functions are, this is back to definitions, language, right? If you're in a cooking class and they're talking about oils and oxidization and all that kind of stuff, you need to know what they mean when they're talking to you about burn temperatures or high heat, low heat, all that kind of stuff. Oh, right. And I obviously don't know. I remember some things. But anyway, we have some standard thinking we can look at. We know with rational functions and reciprocal functions, anything that has a denominator, anything that's being divided and it has a variable, we need to check for any division by 0. That's a standard thing. We cannot divide by 0. We can. The thing is it's not defined. It's not defined. Think about why, and you just enjoy that. Just why can't we divide by 0? Why isn't it 0? So we'll look right there at that x plus 5. Find the denominator. Denominator, bottom part of a fraction. Fraction bar just means division. This statement is just 3 divided by parentheses, because we want the quantity x plus 5. This is important. And division is not commutative. It is not associative. We cannot break it up. We need to just divide. We need to do the parentheses first and then take the 3 and divide by whatever we found. All right, so right now, though, we're going to set this equal to 0 because we need to know what values x cannot be. Does this make sense? This is a common algebraic strategy. It is basically we're saying blank plus 5 equals 0. Common, important Blank plus 5 equals 0. Well, the opposite of 5, negative 5. If we have 5 and we take away 5, we'll get back to 0. That skill is repeated all of the time. And in your life, when you make decisions, do I have enough of something? How much do I need, right? All of that is there. Cool. That is also x equals, so on an x-axis, negative 5. So let me just scroll down. Nope, it's not letting me scroll down. But anyway, here would be negative 5. That should be a vertical asymptote because it cannot be over here. So I already know it's not this graph because we can't have the graph cross where x equals negative 5 because that will cause division by 0, and we can't do that. So we know there's a vertical asymptote. Woohoo! So that will help me graph. This -1 now, that's interesting. The standard vertical asymptote is at 0? No, that's it right there. So horizontal, that's what I'm talking to. The horizontal asymptote, said the wrong word. Horizontal is at y equals 0. But this, remember this shift up or down will shift our whole graph up or our whole graph down. So if the standard one is at y equals 0, kind of like the midline for sine and cosine, we shift it down to -1. So this one does have looks like a horizontal asymptote at y equals -1. One of the reasons is this can't ever really equal 0. Thinking now about range. Vertical thinks about input. Horizontal thinks about output. Domain is what can go in. Everything can go in, and we're going to talk about set notation here in a second. I have to review it. I get these symbols confused. That should be union. That should be intersection. Union means like an and. This means an or. So if I say I will take red or blue, either one will be fine. Fine. If I say red and blue, I need both, right? You have to go get me red and blue. Red or blue, you could bring me whatever. That's kind of the logic there. But all right, we'll talk about that later. Vertical, range, output. This can never get to 0, so that means our output, our f of x, can't ever equal exactly -1. Hence, you have this beautiful, crazy asymptotes that change our graph. So it's not this one, even though the y horizontal asymptote would work. What about this one? No, because look over here, it hits 5. We can't because it causes division by 0. So let me scroll down. Look, all right, here. Oh, okay, I see it. So this one is at +1, and this one, there's that -5. It looks like it crosses it. All right, there we go. So yeah, it's not this one because look, it crosses right here. Boop, it crosses -5. Okay, are you seeing kind of what I'm learning, what I'm looking at, and then what I'm looking for? Perfect. That's a great skill. You find what you're supposed to look for. Okay, I cannot be x equals -5. So if it crosses the vertical x, boom, like right here, it crosses it. I was like, oh, that's not it. I thought this one was it, but it's not because even the horizontal's up. It needs to be down. So let's try it. See, here's this horizontal. It's never really going to touch -1. And then these vertical asymptotes. Notice I didn't talk about the 3, the stretch, because at this point, it's so hard to tell on these graphs, for me anyway, without plotting the points. Let's see. We did it! We did it. Okay, let's go look at notation now. Okay, really quickly, actually. This is a very quick skill. What are the vertical and horizontal asymptotes of the function? It's quick. This should be our y. It's not going to get there. Y equals 3. When the denominator, just the denominator, x plus 1, when that equals 0, what value of x makes that equal to 0? -1, right? -1 plus 1 is 0, so -1. That's it. A good one. Quick, easy, look specifically for those things, plug them in, trust yourself, check your answer. If you get it wrong, say you got confused and you did them backwards. don't panic. Check your work. Try again. Okay, like, wait, it's got to be something like that. What's going on here? Oh, all right. Correct answer 3. Then you type in 3 and you're like, well, where'd they get that 3 from? Oh, there's a 3. Negative, right? Think about it. It's fine. Let me look for set notation. Again, look for those asymptotes. Fine, look for those asymptotes. Look, x can't be 0. They all have a vertical at 0. Okay. Now I know there's some notation in here I need to get to. Look, positive 2. Oh, here it is. Here's the notation. Excellent. This is what I wanted to talk about. Domain. When they say domain, we're going to look only at the x values. Well, there's only one value x can't be. Only one number that x can't be, and that's positive 2. It can be every other number but positive 2. So this one won't work because that says every number. Negative infinity to positive infinity. Doesn't work. Negative infinity to 4. They're checking over here if you think that 4 has to do with domain. That 4 is a shift. That has to do with range. That has to do with our horizontal asymptote, that our output will never quite reach 4. So if this was for range, it would be this one because it wouldn't quite reach 4. Get close to 4 and positive infinity. It'd get close to 4 and negative infinity. 0, no, that's the standard. Aha. Ooh. Oh, so they're looking at the sign. See, attention to detail. Negative 2, negative 2. Nope, I want positive 2. I want positive 2 because that's what x can't be. Whew. Hey, they do the math for you. That's what this notation means, right? It's an interval, meaning we can let x, parenthesis, go down to negative infinity. We can let x come really close to 2, but can't quite hit 2. That's a curved parenthesis. If you remember way back, we had square brackets. The square bracket would say we could hit 2. X can equal 2, but it can't go greater than 2. For right now, it should be mostly parentheses because we're looking for those excluded values, up to but not including those values. Domain, you can try that one. Let's look for range. What is the range of the function? Let's think about this. We know we can't divide by 0, so 3 divided by 0 won't work. There is no shift up or down. Can it ever equal 0? Can it ever equal 0? Is there any value that we could put in there that will not make it undefined to make the output 0? So our function will never equal 0. In fact, there's just a nice symmetrical, if you graphed this, it would be, here's our y-axis, here's our x-axis, and you just have like, I don't know how, it gets pretty close. That 3, right, something like this, just kind of changes the value. Oh my gosh. It does not supposed to touch, but our asymptotes is that 0, x can't equal 0, and y won't. It could if we could figure out a way to do it, but right now it can't because we can't figure out a value we could put in it so that once we're done putting that number inside, out spits 0. So then we have to click this one. And you can always graph it and just kind of look. You can use visual graphs. Do it. It's so important. All right, let's move on. Range again. So remember this notation. So it's going to be, I'm going to talk about it because of this +4. Range is our output. If we could figure out a way to make 5 divided by the quantity x plus 8 equal to 0, then our output would equal 4, and we'd be done. We'd have every value. There'd be no restriction. But we can't. So remember, that's its horizontal asymptote at y equals 4, and the asymptote is a line that the graph will get very, 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 very close to, but never touch. And I want to Google that because I want to internet search it. I got to stop saying that. It's like saying I want a Kleenex when I mean I want a tissue. Kleenex is a brand. Google is a brand. I need to search about that because I remember horizontal asymptotes, sometimes we'll define it, but we can touch it and cross it and just stay really close to it. That's what I remember. That's what I remember back when I was in school. And I remember thinking, that's not nice. Like I before E except after C. And then there's a ton of words where that doesn't hold true, right? Don't say that to me if it's not always true. Anyway, y equals 4 is a asymptote because that's where the graph is shifting. That's where our function, our output will never reach. So now we can't pick this one. We have to think, well, what notation represents that? This says that y can go to negative infinity up to -4, union -4 up to positive infinity. But see these parentheses? It means we're excluding the value of -4. That's not what we want because this is not looking for the opposite, like -4 plus 4, making it 0. Nope, that's not what we're thinking here. This is different than our x value. We need to know we can't quite get to 4. So we're going to pick this one, positive 4, exactly what that plus number is. And it doesn't even have to be a whole number. It could be a decimal, it could be a fraction, it could be a rational number. Okay? All right. Oh, I got to put it in there. Okay, again, you have some other practice problems. Ooh, try this one. Reflected over the x-axis. That would be outside of the function. Okay? Outside of the function. So if this is our original f of x and you're looking at our g of x, if our g of x, was reflected over the x-axis, then it would be -1 over x, or this is the same as negative on the outside. These are the equivalent, same. Where the negative symbol is, it doesn't really matter. Sometimes we typically don't put it in the denominator. We either put it out front or up in the numerator, but they're equivalent. Okay, that would be reflective. Is there any negative? Nope. Okay, so it's not that one. Now the y-axis, we haven't really talked about that one just yet, but the negative symbol is inside of here, right next to the x. That would be a reflection. So that would make our new g of x, so this is just a new function name, g of x would then have to be equal to 1 over negative x. Mrs. Reynolds, that's exactly the same thing. It is. It is. So how does that change things? It would change things if inside of here, right? Oh, and it might be if that was a +2, an x minus 2. Ooh, let's do this one together, right? Because we have our a over x minus, what they say, h plus k. This minus means it's the opposite direction. So then it should be, if this was a reflection, a negative. There we go. That's what it would look like. And then if it's the whole thing, it'd be a negative. Oh boy. Let's click. No, that's false. That should be false. The vertical asymptote, vertical, yes, +2. Oh, +2, right. So no, yes, shifts right 2 units because we need to the right. Get your directions, me too. Shifts up, yes, false. Okay, this is the only one I am not sure about. The graph is reflected over the y-axis. Let's see. Oh, okay. I won't get into it, but I'll let you, because it's distributive, right? The negative sign can be distributed. So if this was the standard, like, does x plus 2 change it? Do I have to have a negative right here? What's happening up here then if this is also a negative? Well, the negative divided by a negative would become a positive. So this reflection is over the x and the y axis. They might be really symmetrical. They might be related. And it would have to do with the original function. Lots of thinking. Never stop thinking, okay? Okay, that's it for today. Wasn't as quick as I hoped, but that is your mini lesson, talking about practice problems, thinking about the notation that we have learned, right? Reflected over the y-axis, you notice how this negative becomes negative x? Well, one of the problems, let's go Desmos. And you are free to stop watching this if you want, but if our regular f of x, and this is something you can do, oops, is equal to 1 over x, what happens when we put, let's see, will this work? Oh, no, it won't work. Okay. So if you have this, could we do negative f of x? Aha, look at that. So why won't you let me do this? Oh, it does. Do you see how they're the same? This is what was going on in my mind algebraically. The reflection for this or standard one would be the same across the y and the x axis. When it starts to change is when we have this, let's say, plus 2. Now the shift is a little bit different. Do you see the green and the blue? The green and the blue will change. It's just harder to tell algebraically from the standard function. Watch, let me make this a minus 2. The green now changed again, right? And then if this is a negative, so if I wanted to make them the same, I think I need to put it down here and up here. No, the shift, -1, negative x, because it would constantly change them. Yeah, so there you go. You need to be careful here depending on our original parent function. Desmos is letting me explore these rules right here. Negative on the outside of f of x, negative on the inside of f of x. F of x is function notation for whatever function I'm working with. So I can come back to Desmos and I can say, oh, okay, I got it. -1. If this was my original function, it could help me figure it out. What if it was just exactly like our problem? Let's try it. Remember what it was. I think this was -2. Oh, whoops, no, f of x. Hold on. There's our original f of x. Then they said g of x. What was happening to it? Well, we had f of x, what was it, +4? So now it's moved. And we had a +2. Something like that. Let me get rid of this. So it would be shifted up 4 units and over, oops, nope, -2. Okay. To the right 2 units. So it's shifted. Is there any reflection? No, okay. So this is shifted up over 2 and up. So if we shifted like this point over 2, hold on, what is this? I want tick marks of 1. So let's start with this one. We've got -2.5. So then that would be over 2.5 and up 4. So if this is a half, we should be -0.5 should be up at 3.5. Yeah. Look, see, 3.5. Right there. It's hard to see. There it is. Okay, there you go. Right? If I look at this point on the red, my original graph, and again, you are free to stop watching. I just wanted to show you this, which is 0.5. Negative. There we go. Okay, here it is. This is going to be shifted to the right 2. That's what this means. All right, let's go in there. X minus 2. Let's go back to our notes. See f of x minus c. Horizontal translation right, c units. Okay, that's check 1. Let's go back to Desmos. And then this +4, see our f of x is plus d, vertical translation up d units. Let's come back. -2.5. So we're going to go to the right 2 units. 1, 2. We're going to go up 4. 1, 2, 3, 4. And algebraically, you can see that negative 2 plus 2 is 0. Negative a half plus 4 is 3.5. So over 2 up 4. Thanks for watching. Thanks for thinking. As always, on these days, I'm just an email, text, phone call away.